So Albina asked about assignments 2 and 3. You will be getting those soon. I've started, and I understand. Yeah, I'll be grading those shortly. Um, I've been making my way through. I started with the first section for assignment 2, and I'll be getting assignment 2 and 3 sort of done in the coming week, hopefully. And I'll mention this with the final project proposal, but the I'm hoping I won't be as behind with grading once you guys submit your final project proposals. But with the proposals, I will be prioritizing those. So for those, you'll definitely be getting that back the week after you submit it, and for the final project proposals, there will be more, you know, like the feedback there will be more important because be it'll be sort of directing the final projects as you're working on them. So there's really meant to be, like with the final project proposal, with assignment 6, and with the final project itself, it's there's more back and forth with the final project. So I'll definitely make sure that the final project proposals definitely get prioritized there. And so with that, we'll get started. So let me get back to where I want to start here, and then I'll start sharing my screen. Cool. So can everyone see my screen? I'm just showing the assignment 4 PDF. Cool. Cool. So what we'll be doing is for this class, we'll be going over Module 4. I actually ended up adding some more examples to Module 4.5. It's still on a separate branch, but I'll merge that, and you'll be able to see it within the course GitHub page. And I'm hoping I'll be able to go through just a few of those examples. And to start out, just in general about the sort of where we're moving in the course. So Module 4 was more using Dash, but really more Python oriented. And for Module 4.5, the kind of filler module that I included because we had an extra meetup, it's meant to be a pretty lightweight assignment, and also it's I mean, really what we're doing is I'm just using this as an excuse to try to get people introduced to Flask, which can come really in handy when using tools like D3. And just one thing I think it's helpful to reiterate as we're moving into sort of the later sections of the course is I mean, the course is meant to be pretty much a survey of different data visualization tools, and so we've in the beginning we're sort of skipping back and forth between R and Python, and as we now move on, we're sort of moving more into D3 and JavaScript. And for Flask, and for I mean, like for other courses in your program, I know you guys are mostly focusing on R, but you do also cover Python. So R and Python, I sort of consider that's the core of what you're learning. So those are and actually I I also mentioned this earlier in the course that you know the while the sort of master's overall is more R centric, I I am sort of giving pretty equal weight to R and Python, and Python, and actually with 4.5, I'm putting a bit more weight onto Python, and that's just to sort of you know make sure that there is an even sort of weight in the program overall between making sure that everyone gets sort of more equal exposure to R and to Python, not sort of at the exclusion of Python. And the so that's sort of what I consider more of the core of the program. But something this isn't a web development like we're not really meant to be web developers at the end of this course. So while I am going through D3 and Flask, it's I mean really I would sort of characterize it as you know the goal is to learn enough about D3 and Flask to or JavaScript and Flask to get yourself into trouble basically. The your there's a lot, like especially with Flask, like there don't get too worried if there's you know if maybe there's sort of copying and pasting from sort of examples that I provided, or if it feels like there's not a as deep an understanding as what you guys are working with in R and Python. It's because really this is meant to be sort of taught in a survey style. Like each of these individually could probably be a course on its own, and so it's difficult to try to fit everything into one course, but like I'm hoping that maybe rather than sort of being experts on everything, this sort of gives you an idea of sort of first of all the directions that are out there, that you would need to choose if you're choosing a data visualization sort of environment, or depending on what sort of stack you may be using professionally, and also sort of giving you more conceptual understanding. Like I focus a lot on the more conceptual understanding of web development, and then sort of allowing that combination should allow you to really know what sorts of things to dig into wherever you choose to dig. So um, I just want to sort of put that out there. Like there's a lot that's being covered in this course, and there's not it's impossible in one course to become experts in everything that we're covering. So especially with the sort of, and in general, this is a data science master's, so don't get too worried about as we're sort of going through more web development concepts. Don't try not to get too worried about getting more involved with those. So with that being said, I'll get into module 4 here. So we'll go over module 4, and I'll show off the new examples I added to module 4.5, which should help sort of bring bring into context why I'm including that, and then hopefully talk a bit about the final project. So for module 4, I'll just start with looking at the PDF here, because this was actually a bit more complex than I made assignment 3. So like this is bringing in some themes that we were working with earlier in the course, where part of the assignment is sort of the dealing with a sort of dealing with sort of like how to answer a broader question, and what kinds of how these sorts of questions drive your visualization types. So before I show off the app, I just want to sort of get an idea of everyone else on the call for these questions. So starting with question one, what visualization type did everyone choose? Cool. So Albina mentioned. So I actually find this fascinating. This this assignment four was like this is the first semester I assigned this one, and I yeah, and it's the same thing was with section one. Everyone pretty much everyone chose bar charts to answer actually both of these. So for question two, what did yep, and Medi pi was what I ended up going with for question one. For question two, well, actually, and yeah, just to finish mentioning the so I found it interesting that the that sort of the choices that I was seeing in the previous section and with you guys. So that's sort of interesting there. And then Albina mentioned that pies are bad when the proportions are similar. That's true, but because for question one we're only dealing with three categories, it's um, it's still useful. The so yeah, like that's sort of a good thing to be thinking of. That pie charts are best used when you sort of have more of a variation, but yeah, and and yeah, it's so it's not so that's not a bad thing want to um, to want to avoid pies. Yeah, and as Albina mentions, things like 32, 33, and 35 are all going to look the same. It's so debatable, and definitely if there were more than three categories, I wouldn't use a pie chart. But because we're dealing with sort of a smaller number of categories, it's okay in this case, I believe. So and then for question two, I um, I thought question two was interesting as well because part of the I thought I wanted like this one to be a bit trickier because the when we're looking at in this case stewards and we're comparing like do stewards have an effect on the health of trees, it's a so a question like that. So if you're asking if X has an effect on Y, something like that. And most of the time when you're thinking of questions like that, the at least this is the case with me, and I imagine uh, this is the case with me, where you think of a question like this, and you sort of first think of numeric variables, where if you want to see if X has an effect on Y, you make a scatter plot and perhaps draw a best fit line and see what the what the effect is there. But because we're dealing with not only categorical data, but pretty like categorical data with not that many categories, it's sort of like that's not going to be the way to go. You would have a scatter plot with 9 points on it, and they would all be overlapping each other. So what did people choose for question two? Heat map, cool. Yep, that's what I went with as well. And yeah, so Mehdi mentioned that there are more trees without stewards in all health status. That's true. So did anyone else run into, or I mean, it's that's the fact of the data, but did anyone find a way to deal with this? Yeah, so it is true that the that not that I didn't want to go to my code yet. So it is true that there's you know that you have sort of problems with missing data in this way. If you were just approaching this like a sort of if you were approaching this like a sort of any other data science problem, and this was what was happening with the data, what sorts of strategies would you perhaps use? So, so basically, when like if you were concerned about measuring the impact and you had this missing data, the yeah. So and maybe I'll get to that in a second. The like when you have missing data like this, one usually the go-to strategy to deal with it is to sort of just deal with the segments of data where you do have complete data. So in this case, sort of getting rid of cases where you have where you don't have and actually I think I misread this here. So you're, I'm sorry, Mehdi, I misread this here. So when you say without stewards, you mean stewards where it's like steward is marked as none, right? So yeah, so the that's right. So it's yeah, so there's nuns and there are also not not a numbers. The so if they're not a number, you could just remove the null values. And this is kind of confusing since none exists in Python as well. But in this case, none is referring to the string none, and what it really means is there are no um, there are no stewards. So in that case, that is still giving you information. You have and even if you have something where most trees have, if they do have stewards, they have one or two stewards. So even even assuming like you're just looking at you know trees that had stewards and trees that didn't have stewards, that's giving you information. What's not giving you information is if it's a null value. So if the the amount, if the number of stewards that a tree has is not known. It's, and I was just getting confused because I saw none, and I was, of course, it's just a very confusing classification there. But you are able to deal with sort of the case of there being no stewards, like that's still providing information. But but if there's just no entry for it, then that's not providing information. And yeah, so in terms of that, and the sorts of like what sorts of issues were people running into with Dash? Perhaps we could talk about that a bit as well before we dive into the homework 4 solution. Okay. With and so hmm, ooh, Peter, you had click interaction. What be interested to see what you were using that for. Yeah, and it's so click interaction is definitely possible. It's and I'm glad you were able. It seems like you were able to figure it out, and that's I mean like that that's one of the things that that I love about Dash is it has more. It makes it a bit easier to sort of um, to deal with that sort of what could be called cross filtering, using one graph to influence another. And Albina mentioned managing exceptions, and the yeah, so the that was one of the so um, I'll get to that, Albina, and then one other thing I wanted to address was the focus. The so I mean the focus is supposed to be both of these, making sure Dash works and sort of like um, it's so it seems like there was perhaps like for in terms of Dash compared to Shiny, like what was everyone's sort of experience there in terms of sort of the comparative learning curves? Because like especially with what Albina mentioned about managing exceptions, like this is something happens with that also happens with Shiny, where and actually also I'll just go into what my solution looked like, but the but basically the when and actually that was the where was I? The I'm getting lost in the chat here. The so when like one of the things that I sort of wanted to highlight with Dash and Shiny, but more so because the Dash assignment was more complex than the Shiny assignment, just conceptually, not even sort of addressing which tool is perhaps more complex. But the so basically, with tools like this, like when you're building a static visualization, you know what your data is going to be, because it's static. You're dealing with one data set. You're not dealing with interactivity. So um, you're able to do things like in previous assignments where we've dealt with outliers by providing labels. You're able to deal with that in a more ad hoc way. You look at you sort of try out a few visualizations. You see what your data looks like. You see where your outliers are, and deal with those outliers one by one. Whereas with something like Dash or Shiny, you don't have that option. So if and none of these graphs are we just have categories, so we're not dealing with outliers. But if we did have outliers, we wouldn't be it's like pretty hard to try to. I mean, you could try do calculations based on standard deviation and stuff like that. But in general, it's harder to sort of deal with outliers and stuff like that in that way. So, and the way that that kind of expresses itself with this data is you have these in this case we're dealing with missing data essentially. So the question is how do you deal with sort of these cases where there are fewer trees and perhaps like actually for some trees you'll have, let's pick sugar maple. I believe we'll have no um, let's try something like oak. I'm trying to pick a. If anyone, I grew up in the city, so I don't know trees. But if anyone knows what would be like a more popular sort of eastern tree, fir. Nope, that's a western tree. Black maple. So I'm not getting what I wanted here, but basically the it's just an oak tree, English oak. There we are. Cool. So the like most most trees don't have four or more stewards. So you're dealing with a lot of sort of missing data data points like this, and that's part of the that was in this case um, meant to be part of the challenge. Although the perhaps what I'll try to do is sort of spread out like some of these different concepts, because it's Dash is arguably a more complex tool to use, and I made the assignment more complex, so it sort of just might have been kind of a combination of sort of confounding complexities that that affected things. But so basically, like whatever, uh, like I'll be a bit more, I'll sort of take that all into account as I'm grading it. So, don't worry too much if there were edge cases that aren't being dealt with in as elegant a way in your in your examples. Um, and then let me just catch up with the chat here. So Mehdi asked, so yeah, Mehdi, you're talking about for the second question. You're actually right, and it was and and a bar chart is actually providing. It's technically providing more information. Something like a heat map is just more um, sort of more of a go-to when you're looking for sort of correlation exactly, like the relationship between two variables. But what a bar chart actually gives you is more, and I imagine it was a stacked bar chart. I imagine, was it, or like since you're dealing with multiple, like a lot of students in the former section were using stacked bar charts for the second question, and the and 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 that actually, yeah, it could. The benefit that, so yeah, Mehdi mentioned that he didn't see any additional benefit in this context. The only additional benefit I really see is it allows you to see more visual, like a heat map lets you see things more comparatively, whereas a bar chart, you're basically like picking one of these dimensions, and you're saying, actually, now that I'm thinking about this more, I think this is why I didn't choose a bar chart, because the I was like a project I was working on previously. I basically there were a small number of categories and then a larger number of categories. So something like four categories on. Imagine if we had four categories on the y-axis and 12 categories on our x-axis. And for something like that, and I actually believe I was also looking at it over time. I'm not, yeah, I think it was over time I was looking at it. So, also the type of variable that you're looking at might drive the visualization type. But, if you, um, uh, actually, so I'm sorry, the project I'm thinking of, I was, um, I was looking at an area chart versus a stacked bar chart. And, an area chart you could actually think of as almost similar to something like this, where it's like the area chart is actually, I might, yeah, I think actually that's not as related as I'm thinking. So either way, like, I think I'm just sort of going down um, a rabbit hole that's not super helpful for this, but so stacked bar chart works for this. Stacked bar chart will give you, more information about sort of absolute, values. So if we're looking at like number of stewards as our x-axis, for example, we would be able to more clearly see that, there's, sort of looking at just this, category, like there are more trees overall with with, in this case, like four or more, because I imagine there are a lot of oaks in parks. The you would have sort of, you'd be able to more clearly see there's more of these trees overall with four or more stewards rather than no stewards, using this as an example. But otherwise, either way, like it gives you, information on these sorts of comparisons. So I think either one of those would end up working. And then similarly for, if people use bar charts for the, for viewing the health, or if you guys had other choices that perhaps we're not talking about right now. Obviously the a lot of like in this case, there are a few different ways that you could arrive at answers like this. So with that, we'll just go into the code of this app. So I'll go through sort of a few strategies that I use to deal with this. So this is sort of on the theme of the on the theme of like you're bringing in your data, and you like when you're working on an app like this. So basically, one of the first things I did was build my lists of trees and burrows, and I'm actually grabbing that from the data. Like a lot of people were doing, we're doing this in Shiny, but just to sort of highlight in the context that we're talking about, you're reading data in from an API, and this app is meant to be able to explore that data without having to be, like without having to know what trees are in there, or even what burrows are in New York. So if we magically add a new burrow to New York, or if there are new trees that start growing, new types of trees that start growing in New York, you would be able to update it depending on what the data is telling you. So that's one sort of thematically related concept that to what we were talking about with sort of the edge cases, and then to sort of look at what I was doing to deal with these edge cases. I ended up using, so Pandas has a concept called categoricals. So these are similar to in R, when you have factors, it's sort of a similar concept to that. And this I essentially used to I used for a few things, because first of all, these categories are ordinal. So, or at least the health categories, again, this is ordinal also. But the you have these categories are ordinal, so I don't just like the order of them is somewhat important. So I wanted to sort of include an order to them, and categoricals let you do that. So here I'm sort of including my categories, and I'm including an order also. So one of the kind of archetypical examples of this you could think of is if you had a data frame with a column of months, and you wanted to order by sort of the months of the year, you would be able to do that, pretty simply. Pretty simply with categoricals. And I was just reminded of one earlier chat I didn't address. I believe it was Mehdi who mentioned that who was talking about deployment. So one thing, and I mentioned this in the assignment PDF. Yeah, so in the other assignments, I was trying to focus on sort of the deployment of of whatever it is you're creating. I want it because I sort of wanted to try to make these assignments like a bit more a bit more sort of real world examples, like similar to what you would face professionally. So you know when you're building, especially with Shiny and Dash, and when we get into JavaScript, when you're building apps like this, the goal is you're creating these apps for professional consumption, and so most of the time you're not going you're going to be developing locally maybe, but in most of the time you're like part of what you want to achieve is going to be deploying the app. And when you're working with this professionally, you want to be able to have the app accessible to whoever is accessing it and who needs to access it. And the the deployment is a big part of that. For Shiny apps, it's the deployment process is just so much more smoother at the moment than with Dash. So I definitely wanted to make Dash deployment optional. So to kind of tie this back to the question about the to tie this back to the question of like what the focus was, like the focus, I didn't want to be on deployment in this case, because deployment is that sort of involves it's not trivial, and while it would be professionally helpful, so I did include it as optional, the you know like deployment isn't that's sort of too much going in a wrong direction. So that's just one thing I hope didn't take up too much of everyone's time. And I'm just checking a few of. So Albina, did I miss a question of yours? I think I did. Albina, yeah. So the multiple functions within callbacks. The so basically a call like um, when you say multiple functions, do you mean like multiple outputs, or are you talking about sort of defining functions within a callback? Okay, yeah. Um, so basically, the like this is sort of a key difference between Dash and Shiny. Is Dash is very much you can almost say it's centered on outputs. So in this case, like I have, it's not too sophisticated an app. I have two drop downs, and these two drop downs are controlling controlling the two graphs. So I so I change any of these, and it results in a change to both of the graphs. So like if you remember when we were introducing Shiny, I had that slide where you saw sort of inputs and lines being drawn to outputs. So you would see something where essentially a line is being drawn here, a line is being drawn here, and then they're going across. So basically each drop down is affecting each graph. Is what that means. And if you were writing that in Shiny, you would essentially just all put it all in one server object. So you would, have your server object, you would have your inputs as variables, you'd have your outputs as variables, and sort of all in one go, you would sort of have them, controlling each other. In and so basically like with the way you could sort of look at the the Shiny server object is as one giant callback. For Dash, you have to have a separate callback for each output. And someone in the previous section mentioned like they were confused with sort of because the nature of interactive apps like this, you know I could I could look at so the student, they were asking like, how do you have one input controlling two, what happens if you want one drop down to control two graphs? And, that's just sort of the nature of looking at, more complex apps like this is I could, think of, I could think of it in that way. I could say, how do I get this drop down to affect both of these graphs? Or, you can sort of look at it the reverse way, like how do I get, this graph to take in values from two drop downs? And that's, like Dash is meant to be more output focused, so that's really the best way to think about it. So looking at the output structure I have, um, you'll see the inputs are the same in both cases. So the inputs here, you see have, I have the same drop downs. I'm just tying them to different outputs. Um, yeah, and Albino, so Albino, you mentioned sort of intermediate values, and that's more comparable in Shiny to like reactive apps. If you remember when we were going through that, that was actually where we had these diagrams. The and yeah, and Peter, section 5, thank you for pointing that out. The so Albino, where um, I'm curious, were you using drop downs as your controls, or were you using something like tabs? You're using drop downs, okay. Like for the drop downs, I mean, I'll check it out when I get up to grading this assignment. But the for the drop downs, you won't have to worry, at least in sort of an app of like this sort of complexity. You won't have to worry too much about sort of passing down values. Some students were choosing to use tabs, and in those cases, you do have to worry a bit more about. So that makes sense. The yeah, so uh, yeah, and Peter, you mentioned it was section 5. I actually was misplacing the section um, when someone else was asking about this, but um,
So maybe it's easier if I just speak very quickly while you're looking. So as I
yeah.
mentioned, after I did this homework assignment, I decided to try something at work and basically rebuild a Click dashboard that I had, trying to put it into Dash. And so because I had multiple tabs in the clipboard, I started looking into tabs for Dash as well. And so what I found so far is there's like one render tab function, for example, that basically is going to be if else if statement, that would point to different tabs. However, like I found that the code becomes very long and too messy. It's kind of hard to keep track of your different brackets, etc. And I was wondering if there is a way to kind of just make it a little bit more tidy. And that's why I was thinking about functions as a way to maybe so I can see the structure of all of my, I guess, HTML components, etc. And then kind of below that structure have the definitions for functions, or something like that. So I was just trying to figure out a way to make it more organized, and visually pleasant, kind of. That's why I was
Mhm.
asking that question.
Yeah, and so basically, I mean, just in terms of organization, the the like what's best to do in things like that is to sort of essentially create like layout sort of larger layout objects, and so that at least like here I have a bunch of divs, and perhaps I would want to take this chunk here and make that like a cell or something, and sort of deal with things in larger chunks in that way. That's a pretty good strategy to sort of cleaning up to cleaning up your code. And
What do you mean? Can you clarify?
so yeah, so if I so so basically if and actually to try to relate this to the sort of app logic that you were using. So and and I wish I were finding because we have like a nice and simple example of but basically like so right now like the app this version of the app is a bit like I guess flatter. It's not hierarchical. So but imagine if and actually like yeah, so imagine if I sort of made this a bit hierarchical. So I said I wanted their sort of the first level to be burrow, and then I wanted the second level to be tree. And so technically what you're doing in that case is this tree drop down is actually dependent on the burrow drop down. So what you would end up with is you would have some sort of it's almost like you have you sort of are creating a mini app with each drop down. So let's say like with your burrow drop down, um, and let's say tree select blob equals, and this would include your drop down. Um, this would include like this would sort of like include, you could have this paint in your graph, so you could have like, and obviously this is just, pseudocode, but you'll have something like this, and then you sort of have a main layout. Um, actually, let me do this. So, you have something like this where, you're sort of populating your app with a burrow. So you have a burrow that gets selected, and then once that's selected, you essentially return what you want the rest of the app to look like. And then, um, within this app, you still have so this graph is still tied to the burrow and whatever tree is selected here. This graph is still tied to the burrow and whatever tree is selected here. So um, yeah, so basically the way that your callbacks would look like is this. So let's say so you sort of have like a main, main app, as it were, and or actually, I'm sorry, let me do this. No worries. Yeah, Albina, don't worry about holding us back. I think this is a pretty good exercise to go through. So so you have a layout that looks something like this. So initially the layout is pretty sparse, and then you'll have something like this where the output here is going to be so basically by putting children here, what we're doing is we're populating like essentially whatever is like in between a div, something like that. So we have our output, and then in this case, the input is just going to be the burrow. So we have our input and yeah, burrow select. So we have something like this, and then and this, it's going to be something like return populate app burrow. Um, so we're going to be using that function up here to create a sort of that main app there. And then we're
So
also going, yeah.
yeah, just a quick to clarify. So if say I want to have 4 tabs with 4 different graphs, right? And for each graph, it's going to be a different function. I would define it before even starting app layout. Basically, those functions just for the graphs, and then I would call them in the callbacks. Is that correct?
Yeah, so and that's just in general, like that applies like in R, in Python, like defining functions and then sort of using those functions in the main body of like whatever body of code you're writing. Um, so, but what's and with yeah, so with Python, like that's sort of what I'm choosing to do here. And just to sort of finish off like what this full app would look like. So we have in this case, we're still going to keep this pretty similar to what I had, because we're pulling both from the larger dropdown and the and the smaller dropdown and the I'm sorry, the burrow dropdown and the tree dropdown. So uh, yeah, okay. So something like that. Let's say this is the pie chart. Something like that. So then here, this would be sort of, some sort of return fig. And then you're pretty much going to do this same thing with the heat map. So what's happening here is we have and I'll try to do this in text here. So we have Yeah, so I'm not going to be able to draw all the arrows, but basically your burrow drop down is affecting your tree drop down. It's also affecting your heat map and pie chart. So, and also like you have the tree drop down affecting your pie chart and your heat map, and your burrow drop down affecting your pie chart and your heat map. So does that make sense just in terms of like a diagram of the app logic? Does that make sense, Albina? Ah. So yeah, uh, in the chat, like put if you have any other questions, or perhaps we could we could either either send me an email, or we could even do like a separate office hours on something like this. And if anyone else wants to come in, we could perhaps have a more general session on dealing with this. And what I'll do is I'll also put out an announcement once I find the documentation, which I'm frustrated I can't remember exactly where it is, because uh, like there's basically a ready-made simple example where all it is like selecting countries and cities, but it's this similar sort of, you know, you sort of have a hierarchical drop down. Um, so yeah, Albina, send me an email, and we could perhaps like take it offline there, and then um, it might make anyone else also send me an email or write in the Ask the Instructor forum, and we could talk about perhaps getting like an office hours set up where we could talk about this further, because I definitely think all of this is useful to talk about. Something like the basically with this assignment, like we had Dash. It's like a bit more complex to use than Shiny, and also the assignment itself was a bit more complex. So we're sort of unsurfacing a lot of like complexities that we weren't really focusing on before. And so we're approaching the end. So I'll go a bit over because there are a few more things I wanted to go over. So do I'm going to quickly show off what I added to module 4.5. So and actually, cool. So I added a more complex API. Actually, what I'm going to do is for this, I'm going to just create a YouTube video, and I'll go through this because I actually missed it for the first section as well, and we're also running out of time. So I'll include this. It's the assignment is meant to be like pretty like 4.5 is meant to be pretty simple. Like it's as I mentioned, it's really was meant to be sort of a space filler. So it's a space filler, meaning like you know we had an extra meetup, and Flask is something that it will be pretty helpful with in combination with D3. And it's but it's also as you're working on your final projects, especially you have a choice in what to use for your final projects. You could use Dash, Shiny, or D3. And even if you are using D3, you could you could choose to just do all of your pre-processing ahead of time, and then just have D3 read in a CSV. The only reason I think Flask is really helpful with using D3 is because with D3, you have like JavaScript is not a language that's really meant to deal with data in the other sorts of in the way that Python and R are. It's there are some libraries that are getting a bit better. Like if anyone here does choose to go deeper into JavaScript, Crossfilter JS is definitely a library I would check out, which is it's kind of comparable to it's almost a version of data frames in JavaScript, and it is really geared towards, as the name suggests, cross filtering. So it's it's used in conjunction usually with D3, and it makes that sort of data sort of filtering and stuff like that. Like it makes that just so much easier than it usually is in JavaScript. But using something like Flask, you could get creative with the way that your API is set up. So I'll explain this more in a separate video, but basically I have an API here that is essentially doing my filtering for me. So this is when we were looking at this for Shiny, like this is just the same housing price data, but I'm essentially relying on the API to filter for me. So I have sort of my seasonality and metro coming in. Mehdi said he doesn't see a folder for 4.5. You should see it at the bottom. So if you go to content, it's I actually I literally didn't find this until now, but I was looking all over to try to find a way to move this. But so yeah, apologies that it was sort of hidden towards the bottom, and um, yeah, so that's where 4.5 is, and yeah, just quickly getting back here, like I'm essentially relying on the API to do my filtering for me. So I'm doing I'm using pandas here to do my filtering based on the seasonality and metro that's coming in, and and I'll explain and I'm sort of essentially receiving a sort of seasonality and metro, or using sort of the way I would access this in JavaScript is I would say something like, actually, I'll still create the YouTube video, but I'll just quickly show you this because it's pretty interesting. So, and actually what I want to go to is we have a, so I'm doing, like, I'm not even visualizing just yet. Like this is just meant to sort of get into the data handling, but I'm basically using just d3.json. I'm reading like this get, get this, get San Francisco. And I actually might make some changes in this when I make the YouTube video because I might want to add the visualization along with it. But basically here you could see like I have my, I have my choices there. And then when I go into my console here, you could see that I actually printed out the data as expected. So I have just these dates, these arrays. And the cool thing about this is I essentially used Python to get the data into the exact shape I wanted. And D3, like there's and I'll get into more of this when we're talking assignment 5, but just to give you a preview, like when you're using these D3 functions, like especially D3.csv, you're sort of iterating through a table with D3.csv, but with D3.json, the data is all right there. So what that means, and don't worry if that doesn't make sense yet, we'll get more into that later. But what that means is I could essentially access any of these variables, and I could, like, using this, pretty easily build a Plotly graph, for example. So if I so with a Plotly graph, I could, you could look at these like examples where you sort of have your X and Y being defined, and those are just like, I could just say X equals date, Y equals high, and I could, create my graph that way, like calling the data from Flask. So it's a nifty way of essentially offloading all of your data manipulation into Flask. So I'll definitely like create a YouTube video and get more in depth into how Flask could be used with D3, because anyone who's choosing to use D3, I think it'll be pretty helpful. And we are pretty over, but with the last couple of minutes, I just wanted to talk once more about the final project. So we went over this a bit last week, but are there any questions about what's expected with the proposal? And actually, if there are, and yeah, Albina, I actually, minutes before I started the meetup, I posted last week's video, so it should already be there. And this one I'll get posted probably tomorrow. But to get back to the proposal, and if anyone else has any questions on the proposal, put it in the chat and I'll address it as I'm talking. But one thing I wanted to sort of highlight is the proposals will be due in 2 weeks, along with module 4.5, and you'll be essentially like so basically, like, what you'll sort of need to do is begin to get a direction for your final project, sort of locate your data sources as much as possible. And I'm not expecting like sort of a halfway done final project, obviously, or something like that. But like and as I mentioned before, I prioritize the final project proposal feedback, because I like to really get involved early and make sure that everyone's on track with the final projects, because there's just too much of a risk of sort of getting started on I don't want to say too ambitious or something, but like getting started on a project that perhaps at the last minute one realizes it's not going to work out, and there's scrambling to get it done. So so basically, like, a lot of my feedback is going to be geared towards how if I see an issue with sort of the structure of the data, and what you're looking to do with it might not work in that context. That's definitely something that I will mention in my feedback, and I'll probably ask you to address in assignment 6. And assignment 6 is just going to be, so you can see here, this is all assignment 6 is. It's your, it's meant to be in service of your final project. So it's sort of meant to, be an exercise in like creating a visualization, or, sort of like getting started on your final project, basically. So here, this is more comparable to, something like a quarter or half of your, sort of getting a chunk of your final project done, so that when you are like ready to, you're just that much closer to the final project. Yeah, Mehdi is asking if if the data has to be final, if it has to be semi-structured for the final project. It the so like if um, so you don't have to sort of get your data, in the exact format that it's going to be needed for the final project, because obviously, like that's going to, um, once you do that, that's sort of a large chunk of the final project, really. So but it should be, so, it doesn't have to be structured, but it has to be, but there should at least be a, thought out path to get it into the structure that you need. So, for example, if there's um, so let's say like last semester, I had a student who was looking at sort of log files, and they were making sort of visualizations based on log files. And log files are pretty not structured. It's just sort of a text file where you're dumping different information. And so if, let's say, something comparable to this were your data source, what I would expect is, maybe you haven't gone through this exercise yet, but at least sort of saying like, I'm planning on using these log files. I'm going to maybe use string parsing or something to get. Oh yeah, Mehdi. So Mehdi put another comment saying like using things like MongoDB, um, you know, like NoSQL, stuff like that. You probably won't be using, tools like that. I mean, you may, if you feel that helps, but like really, it's just about like if you have unstructured data, like think about what it would look like to get that data structured. Another example that comes up pretty frequently, that's a bit less related to sort of the data store, is and a lot of students end up choosing geographic data, and I purposefully don't really get into mapping in the course, because that like is, um, you know, I mentioned like a lot of the tools we're using could be their own course mapping. Like GIS is its own subject area, so there's a lot that goes on there. But one of the common, a common pitfall with using geographic data is, and especially geographic data that's at the sort of sub-state, sub-county level, is there's a lot of non-standard geography types. So, if you're dealing with cities, cities could sometimes be composed of multiple counties. Like New York City is technically 5 counties, and you have things like that. You have, if you're trying to, sort of combine data from different sources, you may have school district data that you're trying to combine with congressional district data, and those, like you're not going to like it's I would pretty much say it's vanishingly impossible to sort of make these sorts of reconciliations, just simply because you have borders that are overlapping, and it's just it's not like it's very it's vanishingly difficult to get something like that to work.
So
And
getting actually, I mean, when I first saw semi-structured data, I thought of like probably you're looking not regular tabular data, but it looks like it could be tabular data or anything like a SQL Server data or Access, whatever. But uh, we need to process it to bring to the point when we'll be able to visualize. So that processing uh, will make the original data or raw data into a structured data that would be suitable for the kind of visualization that we'll be doing.
exactly, yeah. So the raw data that you're using, it could already be fairly processed, and it could be something that maybe you're just sort of grabbing data from one source, grabbing data from another source, maybe joining them on, let's say, date. You have two time series data, you're joining them on date, and sort of coming up with using that as your strategy, and something like that is, like that's totally fine. So it's, Yeah,
So you want
I'm sorry, Vaz.
sort of data processing from the raw data into structured data. So okay, so that's what you're meaning. I mean, I am.
Yeah.
When I first saw, I thought that like you were basically telling us that use unstructured data in terms of like tweeted
Oh,
data.
yeah.
That, but it
Yeah,
could be
so
tabular.
oh yeah, absolutely. Definitely, I didn't mean to imply that you have to use unstructured data. You could, yeah, tabular data obviously is, it's just more, there's always going to be some sort of ETL that's being done. Like, so,
Yeah, I got
that's
it.
all I
I got
meant.
it.
Yeah,
Okay, it's fine.
cool. Cool. And I think that should be it. So, yeah, for the proposals, just, like try to, like plan out as much as possible, try to think about like, how you're planning on like getting your data to, match up, like try to be on the lookout for, like, is this going to work? So like what I mentioned with sort of geographic data, if you see a case like that, start thinking like how, try to think through like how exactly you would get that to work, and then you'll get feedback, and that will guide you for assignment 6, and then ultimately for the final project. So, any other questions before we head out?
Yeah, just one question about the last assignment.
Yep.
In syllabus, you said that all the project has to be submitted through GitHub. Um, but on the day of submission, I think GitHub was inaccessible. Like it went through some problem. It was not accessible for I think 2-3 hours.
Oh, for assignment 4.
Yeah, so I just attached my code to you, and
Uh-huh.
once it is fixed, I think the day after, I put all the code in GitHub, and the link is in the email also. Like when
Okay,
you submit.
yeah, that's fine. Yeah, that's totally fine. Cool. Anything else from anyone? Cool. All right. So thank you, everyone, and all. Good luck with thinking on your final projects and with the mini module 4.5, and yeah, I'll go in the forums or in or email me if you have any questions.
Okay, thank you very much.
Have a good night, everyone.